Hi and welcome back to another LeetCode video. Today we're looking at LeetCode 678, valid parenthesis string. It's a medium problem and it's one of these parenthesis problems, but with an interesting twist. And I thought I'd show you two approaches. One that is very, I guess, intuitive, straightforward, which with a recursive approach, and one that is a more optimal approach that is a little bit easier to understand than maybe some of the solutions that you find on the internet. So, well, let's see what we are dealing with. So we're given a string S containing only 3 types of characters: open bracket, close bracket, and a star. Return true if S is valid according to the following rules. Any left parenthesis must have a corresponding right parenthesis. Any right parenthesis must have a corresponding left parenthesis. Left parenthesis must go before the corresponding right parenthesis, right? So we need to have well, a valid bracketing, like so. That we had something like this, that would not be a valid bracketing. So the opening ones have to come before the closing ones, and they must also open and close in the right order. So by this, that will work. But if I add maybe one more, well, we are missing some closing ones. Right, and the twist is the star. The star could be treated as a single right parenthesis or a single left parenthesis or an empty string, right? So they're kind of like a wildcard that we can use. Here we have some examples. So here we have a valid parenthesis. Here as well. Here the wildcard means empty string. And here in the third example, we have to interpret the wildcard as a left opening bracket so that the remainder of the string is correct. And it's guaranteed that we have at least one character in our string, and we don't see any other characters except for the parenthesis and the star. So how do we approach this? Well, this is if we implement this as a backtracking problem with recursion, we have a couple of choices of how to interpret the star. So what we could do is that depending on the star, we could interpret it as an empty string, opening and closing bracket, and we could then continue, try to process our string, and see if that leads to a valid combination of opening and closing brackets. And if any of those interpretations of the star work, then we have to return true. So let's implement this approach first. I like to call my depth first search methods DFS helper. And what are we going to give it? Well, we're going to give it an index position where we are currently in the string and the number of open brackets. And what is our base case? When do we terminate the recursion? Well, if open is smaller than 0, right? Then, well, we need to return false because that means we have consumed more open brackets than we have closing brackets. Like 3 times closing, then open would go to a negative value. Now, the case when we have a correct bracketing is when we've reached if I equal to the length of the string S. Then we just return, well, do we have any open brackets left or no? Return open. And maybe this is not, maybe you don't understand this yet, but let's just wait a little bit until you see it, then you will. So we take the character at the position I. Oh, and I should say how I start this method. So what I do is I just start it with DFS helper. In the beginning, we start at index 0, and we have no opening brackets currently. So right, so now it's about processing the bracket. So if C is an opening bracket, we do a recursive call, but we have to increase our opening bracket counts and our index. So we do I plus 1 and open plus 1, right? So there's only one way to interpret an opening parenthesis, and that's that. Now, if we run through closing one, we also have to advance our index with 1, but we have to decrement our opening bracket counter, and it could go negative, in which case that was an illegal move, right? So we're returning false. Now, the other cases are now if C is a star, right? Well, what options do we have? Well, we could say, we could interpret the star as a closing bracket, right? You have to do I plus 1. And we could interpret it as an opening bracket, as a closing bracket. We could interpret it as an opening bracket, or we could interpret it as an empty string, in which case we don't change the number of opening and closing brackets. So those are the three ways to interpret the star. Right, and if any of these calls returns true, we should return. So what we do here is we will return any of these, and we just combine them maybe with an OR, like so. Either this one, that one, or this one. Any of these recursive calls returns true, then we return also true. Otherwise, of course, we will return false. And that is really everything you need. So let's run the tests. And you can see how nice and elegant that is, how simple that is. And it passes all of the test cases, which is really nice. Now, let's do a quick runtime and space complexity. So in the meantime, I got a little more smart with how to do runtime analysis when we have a certain branching factor in a recursive call. Obviously, our value I can go from 1 to n, which is the length of the string s, right? So, well, we have a component n, but we also have to consider the branching factor. Now, the branching factor is in the worst case 3, right? In worst case, we have to go into all of these 3 branches. In the best case, it's just 1, right? If an opening or closing parenthesis. But if we have a string that only consists of stars, well, that's the worst case, and we have to actually examine all of these different paths. So what we'll have then is we'll have the branching factor raised to the power of how many times or how deep the recursion can go. And we also have to include the runtime of the execution of the method in one of these recursive calls. But because we don't have any loops in here, nothing like that, it's we don't have a factor n here. If we were to iterate over something in here, then we would have a factor of n here. But we only have a constant factor, which of course falls away. Time and space complexity, easy. Well, I can only assume n different values, right? So we will never have a stack space more than O of n. So this is the runtime complexity for this particular case. Now, if we submit this, we might run into an issue because of the runtime complexity. Yeah, it's taking quite some time. The time limit exceeded, right? Because too many different paths to go down. So even though the recursion depth is only n, O of n, there are just too many different paths to go down. So how can we improve this? Well, one thing is we could just add caching. So what caching does, it stores the combination of these 2 parameters that are given to the helper function as a key in a dictionary, and they store the return value of that function when we are giving these input parameters to the function. So when for the first time we encounter this method call, let's say we call DFS helper 00, what we do is we'll execute the function, calculate the result, and then the result gets stored in the cache. And the same for the recursive calls. And this leads to a situation where, we won't calculate, well, we won't call DFS helper with the same parameters and re-execute path of the search tree to compute results. So adding a cache really means that we're going to limit our time complexity, and it actually goes down to, can you tell? Well, we can have I different values for n different values for I, so it's definitely a factor of n. But we can also only have n different values for open, right? cannot have more opening parentheses than n. So it's actually n squared time now, and space as well. That's it. Because we're limiting the number of executions of the helper method effectively by n squared. At the same time, we need to store n squared results, in the worst case, in our little cache here. So that brings down the runtime quite considerably. So if we run this, results, let's submit this now. And we're not running into time limit exceeded anymore. With cache, right? So yeah, so that is all cool, right? Well, now the question is, can we bring that down even further? And the answer is yes, with an iterative approach where we don't have to use stack space, right? And yeah, let me explain you the intuition behind a more efficient solution. So our more efficient solution will be over n time and constant space. Well, and how can you achieve that? Well, if you look at these examples, you know, once we encounter a star, it doesn't really matter where we place it, right? It doesn't matter if we place the star if this expression is the same as this expression. So it doesn't really matter where we place the star anymore. All we really need to do is we need to keep track of the star, right? Or we could place a star here. Same effect. Doesn't really matter. We could use the star anywhere we want after we've discovered it. Just have to be careful to use it when we need to. So here in this example, it makes sense to use star here. And I'm sorry, I misexplained it. So if I put the star here, that is not what I meant. So I mean that if we discover a star, we can use it either right away or a step later or even later, right? But we might run into a scenario like here where we have an opening and closing and another opening. Obviously, it makes sense that we have to use the star before we can close the bracket again. So what we'll just have to do is we just have to keep track of how many stars did we see. And when we have to use it, we just use it. That's the whole intuition behind it, so that the position of the star does not matter. So we just have to keep track of them to use them when we need them. And the way to do that is, well, we will have to count our number of opening brackets. We will have to count how many wildcards we currently have that are not used. And we just iterate over all of the characters in our string. Now, we do the same checks. So if character is equal to an opening bracket, right? Then we'll say open, plus equals 1. If it's actually a closing bracket, well, what do we do then? We have to check if we have an opening bracket. If open larger than 0, right? Then we say open minus 1, right? Because we're closing an opening bracket, an open bracket. Else, if we have a wildcard. So if we don't have enough opening bracket, we have to use a wildcard. So if wildcard is now larger than 0, we have to use it. We have to use the wildcard character. And if we don't have a wildcard character, well, just return false because it means we're out of luck. We also have to add a check here. If we run into the wildcard character, we have to increment its count. Right, and now at the very end, we might still have opening brackets and we might still have wildcards, right? So what we do is, well, we check now. We say open is the maximum between 0 and open minus wildcard. Because we might have more wildcards than opening brackets. in which case we must interpret some of them as the empty string. So that is why the number of open brackets is going to be, the number of left open brackets is either 0 or some positive number. And if we know if we have opening brackets that's larger than 0, we have to return false. Right. Now, but this is only half of the solution, because we also need to interpret it, that the other way around. So when we iterate over the string with a forward pass, and we encounter wildcard, we can never use the wildcard, I suppose, earlier, but we also need to be able to do that. So we also have to check in the backwards direction to ensure that we consider all possible usage of the wildcard character. And it's a little bit difficult for me to explain. Turn true. So if I didn't do it, if I run this, let's run this. Wildcard. So it passes the test cases, but if I submit this, you will see an example where this doesn't work. And this is a little bit long, this example. I wish they had one that is a little bit easier to understand. Yeah, but essentially what you need to do, what I've just said, you start again, but this time you run backwards through the string. And everything else is exactly the same. And if I run this now, wait, let me see. Well, oh, obviously because it's mirrored, we now have to change the open to the closed parentheses, the open one. We'll do here closed plus equals 1, closed, closed, closed. Run into an open one. We need to have closed ones left, otherwise it's not going to work. Submit this now. As all of the tests. So yes, I'm not sure if I explained this well enough, but the intuition lies in understanding that you can place the wildcard characters in different positions and use them in different places. So, and you do that by iterating over it, counting them, and using them up when you have to. And the reason why you have to do it also with the backward pass is so that you are able to interpret them, in positions where they occur earlier than they occur in the actual string. Right. I don't know if that was a very good explanation, but I wanted to show you that. And yeah. Well, and if you can solve it optimally, you can for sure get a very good runtime, which is a much simpler solution using a recursive approach with caching, which is essentially a dynamic programming approach. Right, so this concludes this video.